So previously we talked about different ways to find the equation of a line, and it just comes down to what information you're given to begin with. We always need to fill in y equals mx plus b. We need to figure out what the slope is and what the y-intercept is. So given the slope and y-intercept, we just plug it in. But if we don't have that, we need to use the information that we have in order to fill that information in. So determine the equation of a line that is parallel to the line given and has a y-intercept of -2. So I'm looking for in y equals mx plus b, the slope, and the y-intercept b. So they tell us the y-intercept is 2. Now we want the equation of a line that's parallel to the line given. So it's parallel to this blue line you see there. When it's parallel, that means it's the same slope. So this blue line and the new line that we're going to come up with that has a y-intercept of 2 would have the same slope. So we need to figure out what the slope of that blue line is. So we pick 2 points. It doesn't matter what the 2 points are. We pick 2 points and we find the rise and the run. So the delta y, or the change in y, is 1, 2, 3, 4 spaces. The change in x is 2. So our slope would be 4 over 2, our rise over run, or 2. So now we've figured out what the slope of that blue line is, which means that the slope of our new equation would be 2 as well. So that means the equation would be 2x plus 2. So if we graph that, we have a y-intercept of 2 and a slope of 2. So I go up 2, across 1, up 2, across 1, and I go backwards. So I go down 2, left 1, down 2, left 1, and so on. So we've created a line that is parallel to the blue line and has a y-intercept of 2. So they both have the same slope, and we've figured out what the equation is based on the information. So, example 2, we want a line that's parallel to this, parallel to that, and goes through this point. Write the equation of the line. So again, in y equals mx plus b, we need to figure out certain things. We need to figure out the slope and the y-intercept. Now, I know the slope because it's parallel to this line. So if it had the same slope, the slope in that equation is 2 over 3. So the slope in my new equation is going to be 2 over 3. Now, I don't know the y-intercept this time, but I do know that it goes through the point -2, 5. So I can say that x is -2 and y is 5 in y equals mx plus b. So if I replace y with 5, m with 2 over 3, x with -2, I can figure out what the y-intercept is going to be and then plug that back in after. So let's solve for b. -4 over 3 plus b. So I can add 4 over 3 to both sides to isolate b, which means I need a common denominator. So 15 over 3 plus 4 over 3 would be whatever b is. So that's 19 over 3. So now I know everything I need for the equation, the slope and the y-intercept. The slope is 2 over 3 because it's parallel to the line that we were given in the question. And we figured out what the y-intercept is, 19 over 3. So we know that's the y-intercept because it goes through this point, negative 2, 5. Example 3. So the line is parallel to x equals 3 and passes through the point negative 6 and negative 4. So these questions are actually much easier than the ones we did before because we have a vertical line. X is equal to 3, which means it would look like this. So if we have another line that's parallel to that, it means it also has to be a vertical line, but it passes through the point negative 6, 4. So negative 6, negative 4, negative 6, negative 4 is there. And it's parallel to x equals 3, which means it has to be a vertical line. So there we go, that's our line. So what would that equation be? Remember, a vertical line is x equals whatever the x-intercept is. So in this case, it's negative 6. So our answer is x equals negative 6. So I didn't really need to graph that because I saw I had a vertical line and I know the x-coordinate is negative 6, then I know that my equation would be whatever that x value is, negative 6. So if we have a line that's parallel to y equals 2 and passes through the point 9, 15, since I know it's a horizontal line and it passes through 9, 15, then I know that the y-coordinate is the y-intercept. So it'll be y equals 15. Now we could just quickly graph that so you can see what I mean. So if I have y equals 2, let's say it looks like this. So another line that's parallel to this is going to go through 9, 15. So the point 9, 15, let's pretend it's over here. But it's parallel, oh, sorry, I totally messed that up. Let's do that again. Y equals 2 is a horizontal line. So looks like this. And our new point, our new line goes through the point 9, 15. So let's say it looks something like this. And it has to be a horizontal line, then it must look like that. Close enough, right? So where would it cross the y-axis? If I look across here, where would that be? Well, that has to be 15 because that's the coordinate, 15. So that would be y equals 15, and that's my answer. Y equals 15. Again, I didn't have to graph that. I just know from the question. Okay, so that's parallel lines. Now we're talking about perpendicular. So perpendicular are lines that meet at 90-degree angles, and they have negative reciprocal slopes. So what it means, we change the sign and take the reciprocal of the slope. So for instance, if I have the line y equals negative 3x minus 1, the slope here is negative 3. But if I want to slope that's perpendicular to this, I would take the negative reciprocal of it. So we use this symbol to show that it's perpendicular. So it's the perpendicular slope to that. So I take the reciprocal. So the reciprocal of 3 is 1 over 3. And the negative of it, so it was negative, so now it becomes positive. Okay, remember that any number is written over 1, so the reciprocal of that would be 1 over 3, and the negative of a negative is positive. Now let's look at b. So the slope here is whatever's in front of x, so 5 over 7. So don't get confused because the 2 is first. It's 5 over 7. The slope that's perpendicular to that would be the reciprocal. So we flip it. And the negative of it. So if it was positive, now it's negative. Negative 7 over 5. Here we have a slope of negative 1. So that number that's in front of x is negative 1. So what's perpendicular to that? The negative reciprocal. So the reciprocal of 1 is still 1. But now it's positive because the negative of negative 1 is positive 1. So what we're doing now is this pretty much the same thing as what we did before. It's just the extra step of thinking about negative reciprocals because we're talking about perpendicular lines instead of parallel lines. So the equation of the line to the right, that blue line, is 2x minus 8. So we want to write the equation of another line that's perpendicular to that and has a y-intercept of 2. So what would be perpendicular to that? If the slope is 2, the original slope was 2, a perpendicular slope would be the reciprocal, so 1 over 2, but the negative reciprocal of that. So if it was positive, now it's negative. And has a y-intercept of 2. So we know everything we need for y equals mx plus b. The m is negative 1 over 2. That's the perpendicular slope. Y-intercept was positive 2. So now that we know the slope and y-intercept, we can graph. The y-intercept is 2. And the perpendicular slope was negative 1 over 2. So we go down 1 across 2, down 1 across 2, down 1 across 2, and so on. So there we have our line, which is perpendicular to the blue line. Okay, a line that's perpendicular to negative 2 over 3x plus 1 and passes through that point. Again, we need to figure out what mx plus b is. What's the slope and what's the y-intercept? So the slope I can figure out because it's perpendicular to the original slope, 2 over 3. The negative reciprocal of that would be negative 3 over 2. But I don't know the y-intercept. I know that it passes through the point negative 2, 5. So now I can plug all that information in to figure out b. So that can be my x and that can be y. And now we can solve for b. So we simplify. I get 6 over 2, which is 3, plus b, subtract 3 from both sides, so b is equal to 2. So the slope is negative 3 over 2, and we figured out the y-intercept is positive 2. So that's the line that's perpendicular to the equation we were given and passes through the point negative 2, 5. So again, we're just trying to find the slope and the y-intercept. In this case, we have a line that's perpendicular to x equals 3. So we remember from before, hopefully, a few minutes ago, we saw that that was a vertical line. So x equals 3 would look like that. Now we're talking about a line that's perpendicular to this, not parallel. So if it's perpendicular to a vertical line, we know that has to be a horizontal line. And it passes through the point -6, -4. So the same points we were talking about before. And it's just now it's perpendicular. Oops. Oh, I jumped to a different page. Okay, there we go. Okay, horizontal line. Now, what would the equation of this be? It's a horizontal line, and it goes through -4. So y equals -4. Now, again, we could have figured that out without having to graph it. I know it's perpendicular, so that it has to be y equals something. It's a horizontal line, and the y coordinate was -4, so it must have been -4. Here we have a line that's perpendicular to y equals 2 and passes the point 9, 15. So if it's perpendicular, it has to be a vertical line. It passes through the x coordinate of 9, so it's got to be x equals 9. But if you can't visualize that, let's graph it. We have y equals 2, so that would look like this. And a line that's perpendicular to that and goes to the point 915. So let's say 915 is there, and it's perpendicular, so it has to be a vertical line. And where does it touch the x-axis? Well, at 9. So that means the equation of that black line is x equals 9. But again, we knew that because of the coordinate of the point that it passes through, 915. So there's some practice questions for you to do. The answers for these will be on D12.